All right, let's get started. I'm Jody Collier. Thanks for coming to FABTECH. How many have been to more FABTECHs than just this one? How many is this? Let's just say this. How many is this your first FABTECH? All right, almost everybody it seems like. How many have been to 2, 3, 5, 10, 20? I've been to more than 20. Back before they were even called FABTECH, they were the AWS Expo. And when I first got on with Delta Airlines maintenance back in 1990, and I was permitted to go that first year to the AWS Welding Expo, and I was so looking forward to it. Never been to anything like that before, but I was all pumped up about it. And the night before, the afternoon before, I was doing some yard work and spreading wheat straw. Did not know I was allergic to wheat straw. So I just broke out from my chin to my knees. And back then, like I said, when you flew company business with as an employee with Delta, you had to wear a coat and tie everywhere you flew. So I had to choke the tie on with that rash and everything, but there's no way I wasn't gonna go because I wanted to go so bad. Didn't get a minute's sleep and wound up going, and it was still awesome, even though I was horribly uncomfortable throughout the day. So I got kind of bitten by the bug, and fortunately, I was able to go year after year and only missed 2 or 3 in the past, well, since then, since 1990. So now it's FABTECH, it's even better, it's bigger. Now it's even better because of social media and Instagram. Who's on Instagram? Awesome welding community on Instagram, right? A lot of people helping each other out. I think that's just great. So when ESAB asked me if I'd be interested in coming and talking about something, I said sure, because I'd probably be hanging out here anyway at this booth, So we're talking about filler metal selection for TIG welding today. And it's a deep subject. There's no way we can cover it all, but what I want to do is just kick it off and talk about some guidelines. Oh, I see you're getting handed the Alcotech aluminum filler metal chart. That's a really good resource, and we'll talk about it a little bit as we go. I'm happy they were able to supply that for you because I found that very, very informative. And so anyway, we'll talk about some guidelines for selecting filler metal, and we'll get into some of the more commonly welded metals, steel, stainless steel, and aluminum. And I hope to leave lots of time for Q&A. I'm not really sure how much, if any, I'm going to even weld because I don't think it'll add that much to the conversation, and plus we're dealing with cheater lenses and stuff in this new helmet up until the last minute, so not feeling too comfortable about how well I could do. So anyway, let's talk about 4 rules, and I think the first rule would be there's an exception to pretty much every rule when you talk about filler metal selection. That's rule number 1. If you search online, you'll see things like you should always match the filler metal with the base metal. Not really, not always. Sometimes it's a good idea, but not always. A couple examples come to mind. We often weld 4130 chromoly with ER70 or ER80 rod. We often weld 6061 aluminum with 4043 or something else, 5356 or something. So that's not a match at all, and there's reasons for that. We'll dabble in that a little bit later. Rule 2, or guideline number 2, I would say in selecting a filler metal is that you can't always select the filler metal. If you're welding to a code, welding procedure specifications in front of you, it's going to list the filler metal, and that's the filler metal. And even if you think that ER70S6 flows better than S2, but if it says S2, that's the filler metal on the procedure. That's what was qualified. There might be a reason for it, there might not be, but that's the filler metal. So I don't want to brush past that because it's very important when you're doing coded work and you're working off of some engineering document, whether it's a job instruction card or a process sheet, data sheet, job traveler, all kinds of names for these documents, but if it lists the filler metal, that's the filler metal, okay? Number 3, welds need to meet the service requirement, not just like on the bench requirement. You can weld a lot of things with a lot of different wires, and it's sitting on your bench, it's fine, but once it gets put into service, maybe it's not fine. Like say somebody brings you some 308 or 304 stainless. Take that back. Let's say somebody brings you some 316 stainless and you weld it with 308L, instead of 316 might not meet service requirements because the 316 is much more corrosion resistant. It looks the same, but so you need to know what you're doing there so that the weld meets service. And that can mean a lot of things. You know, it can mean like, is it strong enough? Is it ductile enough? Is it tough enough? That's a song. You know, is it hard enough? And depending on what industry you're doing, like say if you're doing repair on tool and die or injection mold, hardness might be the main requirement. If you're doing something that's going to go in seawater or some kind of other corrosive environment, corrosion resistance is your number one thing, you know, but it's got to meet service requirements. So filler metal needs to be selected with that in mind. And you know, that brings me to this. If you're a job shop type of application and you're not working, you know, it's just an employee somewhere, but so it's up to you to select the filler metal. Communication with the customer is key. Like, where is this part going? What does it do? And instead of just working off the drawing and just making the part and delivering it, sometimes having that little bit of extra information by communicating, like even over communicating with the customer, is a really good thing. Can save you a lot of trouble, you know. So weld needs to meet service requirements, not just be able to stick something together, because a lot of metals are compatible with one another. They'll join them, but then when they're stressed and put under severe environments, they're not going to hold up, okay? And so there was a fourth one. What's that? All right, I've got to check my notepad here. Incidentally, as far as filler metal resources go, if I were to ask you, you know, who's the 34th president of the United States? What's the first thing you'll do?
Google.
He'll be like, yeah, this guy right here. He's, you know, so we don't have to memorize all these things. You can. There are apps and everything. And I was just doing some pecking around recently, and you know, there's ESAB's got this filler metal chart online in a PDF. You can pull that, save it on your phone. But they've also got another one. I think it's Exaton is a company. They're part of them now. They've got a nice little filler metal app on there. So if you go to your app store, search for Exaton. It's also got parameters for, you know, for MIG welding and things like that. But it's also got a selector for stainless steel alloys and things, and it's pretty good. So that's another resource. But smartphones, nice. All right, what was that fourth thing? I know there was one. All right. Fourth thing that might keep you out of trouble. I had a boss that used to say this when it came to deviating from industry norms. Like he used to say, think about if somebody would one day stick a microphone in your face as a result of doing this thing, right? So he was in training. He was a director of training. So, you know, it was aviation training, and so there were certain ways of doing things, and he was very much against doing some special thing or a shortcut or you know, stick with what's known, stick what's been proven and all that. Don't use a special rod just because you think it's going to be better. Use what has proven itself to work over the years. Example, you know, in aviation or aerospace, Hastelloy W it's used for a lot of things, joining stainless to nickel to this to that. It's just used all over the place. But Hastelloy X is not. Both of them are Hastelloy. I had a friend who bought some Hastelloy X off of eBay thinking it was just the same thing, and it's not. So don't just pick a rod that you think is going to work. Do something that there's substantiation and data behind, you know, to back it up. Okay? So let's talk about a little bit about carbon steels, stainless steels, and aluminum, and then we'll see where that goes. And then I want to have plenty of time for Q&A here. That's a lot. Sometimes there's just a lot of benefit to Q&A because I'm going to talk about carbon, stainless, and aluminum. Those are the most commonly welded things, but some of you might have questions on some other things that maybe I have an answer to, and maybe some of you have an answer to. So carbon steel. Mild steel, 1010 to 1020 steel is a super common low carbon steel, very forgiving. We almost always weld it with like ER70S2. ER70S6 works good too. There are little slight differences. In some instances, you can't hardly tell the difference. For me, on an open route, when the backside is exposed to air and you don't have purge gas, the S6 seems to perform a little bit better. But if it's a lap joint or a T-joint, sometimes you just can't even tell the difference in those two. But that's a really common metal, and we weld it with an ER70 rod, but we also use that ER70 rod for welding chromoly, 4130 chromoly. Sometimes 4130 rod is used for welding 4130 chromoly, but usually only when it's a small enough part. It needs to be heat treated, full strength. You know, when you can put it in the oven and heat treat it after it's welded, and you can do all the things you need to do there and get a full strength part, that part is now much stronger than it is if you just weld it and leave it. But a lot of tubing, chassis, monster trucks, roll cages, they're 4130, and it's not feasible, it's not practical to stick that whole thing in an oven and heat treat it. So most of those are done they're welded and as welded, they're just left. So that's why we use ER70 or ER80 SD2 on those welds. And it's proven, as long as it's, 120 thousandths or below. A lot of tests have been done on preheat, post-heat. Typically, as long as it's not in a cold shop, you can weld it, don't have to post-heat treat it, it's fine. But that's just an example of where filler metal does not always need to match, the base metal. Okay? So stainless steels, hold me back up a little bit. Has anybody here ever welded a 12L14 carbon steel? It's called free machining carbon steel, okay? And then the L in 12L14 stands for lead. It's great for machining. It makes the chips come off nice. Not good for welding. It's not recommended for welding. Sometimes you have to weld it. Sometimes it's, I have anyway. And the ER70s tend to work good for that, but you need to, on these free machining steels, you kind of have to use that test. Like, what if somebody stuck a microphone in my face here? Like, somebody was making attach points for big motors that mounted overhead that if they failed would swing down and hit you, and then you knew it was 12L14 steel. I just wouldn't even weld it. But it can be welded. You got to use your head, what the application is. ER70 rod works fine for that. Let's move on to stainless. Most commonly found stainless that we're going to talk about is 304. It's commonly welded with 308. And then after that would probably be 316. 321 is used a lot for high heat applications. These metals are all designed for different applications, different service requirements. And so you need to use the filler metal that will meet service requirements, right? So if you weld 321 and it's designed to operate in an 800 degree environment, and you weld it with 308, it's not going to do the same thing. So just want to drive that point home a little bit. 316, a lot higher molybdenum concentration, needs to be welded with 316. 309 is a rod that's designed to weld carbon steel to stainless steel. It's also got a lot of other uses, just welding tooling and welding dissimilar metals, when you don't really know what they are, but you need to fix something. That's a really popular rod for that. And so let's move on. We'll move on to aluminum now. 6061, super common aluminum alloy. You'll see the T6 at the end of 6061. That's a temper. That's pretty stiff stuff. It's hard to form without a large radius and everything. If you look on your chart, your filler metal chart there, you can find 6061 on one column and find it on the other column, and then take it across and intersect. And what you'll probably see is a choice of filler metals. 4043 will be listed, 5356 will be listed, and then there's a footnote down in there somewhere. It basically will say that if this part is going to be at 150 degrees or higher Fahrenheit, you shouldn't use 5356. Everybody see that? That's one of those things that footnotes, devil's in the details. You get a chart like this, but you have to read the footnotes, definitely. So all that argument about what's better, there really is no one size fits all. It just depends on, will it meet service requirements? Will the filler metal that you put in there meet the service requirements? And if you know, if bad things happen at above 150 degrees, if you use 53, 56, then maybe that won't, maybe it was stronger, but it won't last, you know, so that's a good resource, again, for that. 3003 is another really common aluminum. It's a non-heat treatable alloy. It's used a lot for truck boxes and tread plate and all kinds of things. You know, you can use 4043 filler metal on that just fine. Sometimes aluminum will be heat treated, try to get it back up to full strength after welding, and if it does, you need to use a filler metal that can heat treat. And 4043 won't hardly respond to heat treatment. 5356 won't. So there should be some information on that chart about that as well. Aluminum castings, I really like 4047. You can use 4043 for the most part. Most aluminum castings are a silicon casting, silicon addition casting. There's all little slight differences, but 356 is a really common casting alloy. 4043 is a pretty close match, but sometimes porosity is the main thing when you're welding a casting, like the main thing. Strength is important always, but porosity. And 4047, because it melts a little lower, you don't have to use as much heat. It's actually called the brazing rod. So you're just wetting over an oil-soaked area, and you don't have to draw all that oil up all the time. So 4047 is a good choice for a lot of castings when porosity is the problem. And you know, that's the high points of carbon steel, stainless steel, and aluminum. And I'll get my smartphone out here in a minute and see what else I'm left out. But I think we can go ahead and do some Q&A here if anybody's got anything. Yes, sir.
On one of your recent podcasts about the specialty metals, you mentioned there was a real good source for that, and I couldn't quite understand what you were saying.
A good source
For identifying which filler metals to use?
I'm going to have to scratch my head on that because I'm not sure I remember what I was talking about on that podcast. But we'll come back to me on that one, if you will, after the class. We'll figure that one out. Anybody else got anything? Any questions? Yes, sir.
That 4047 you're talking about, I repair boats, pontoon boats, all aluminum, and they're always dirty because of that. Better. I've been using 4043. Would that flow in better on something like that?
Sometimes. He asked if 4047 could be used on pontoon boats and things like that to flow in better because they're always nasty and dirty. It's very close to the same strength, and it does definitely wet in nicer. It's got about twice as much silicon as 4043. Now let's say that lowers the melting point a little bit. It really kind of flows in like water almost sometimes. So there's a website, a resource. They used to have a lot more than they do now. They were called Rundquist.com, and it's a propeller repair place. So they used to have a whole training area on there with filler metal selection and everything that they had found worked good on props and skegs and pontoon boats and things like that. And they did list 4047 on that one as being something they like to use. Okay. Anyone? Yes, sir.
Can you comment on welding 304 stainless versus 304L?
304 stainless versus 304L. Is there an application that you have in mind?
Like exhaust type tubing?
I think, I'm just shooting from the hip here, I don't think you'd have a problem just using the 304L across the board for filler metal. You know, it's important to have the low carbon for corrosion resistance when the base metal is low carbon. But if the base metal you're welding isn't, and you use a low carbon filler metal, shouldn't be a problem. Anyone else? Anyone else got anything? Anyone? Well, yes, sir.
What would be a good filler metal selection for like Inconel to stainless or Inconel to titanium?
He asked what would be a good filler metal selection for Inconel to stainless or Inconel to titanium. I can tell you right now, the Inconel to titanium, there is none. They just won't They just won't join, at least not for fusion welding. There might be some explosion bonding process or something, you know, really specific like that joins them, but typically titanium is the only thing you can use for titanium, and you don't weld anything else to it, you know, like that. Inconel to stainless, I haven't really looked, but that Exciton filler metal selector, the app, will probably give you some kind of answer on that. Of course, there's about 100 different Inconels and 100 different stainlesses, you know. And I'm going to guess, though, that a lot of times you're going to find Inconel 625 is recommended for that. That's just a really good all-purpose, dissimilar nickel alloy that has been used for all kinds of things in the oil and gas industry. And so there's a lot of data out there on what it's good for. Inconel 625. I think it's ER CRMO-3, something like that. Anyone else? Any more questions? Oh, I probably didn't take up the whole hour, but again, I was having some difficulties with my helmet back here, welding and getting things going, and I thought, yeah, you know, welding here, while I'm talking about filler metal, it's just a way to break up the monotony is more than anything anyway, so I'm not going to do that. So if nobody has any more questions, I'm going to cut it short, and we're done here. So check out your filler metal guide there for aluminum. That's good. That's worth a good study. There's a lot of information there. It takes looking at it a little bit and reading the footnotes, and then also check out that Exciton stainless filler metal app, and I think those will help you out. Thanks for coming.